Okay, so our objective today is we're going to learn the parts of chemical formula. So we're starting a new unit, a new section. We're still in chemistry, but it's a new section in which we are going to look at compounds, what they're made of, how to count atoms within a compound, and then eventually look at what elements join together and bond together to make compounds. So we're going to start off by looking at chemical formulas and what chemical formulas tell us. So our notes today is over chemical formulas, and our essential question is, what's the importance of coefficients and subscripts in the calculation of the number of atoms in a chemical formula? So by the end of this period, you should be able to answer that question. Yes? Can you get what? Oh, do you need colors? So, by the end of this period, you should be able to answer that question. Okay? Now, what a chemical formula is. A chemical formula is just a shorthand form of writing the elements and their amounts within a molecule. So when we talk about a chemical formula, we're just doing it in a shorthand way of writing what a chemical has in it. Okay? You need to know in a chemical formula, you'll be able to know in a chemical formula what elements are part of the compound, how many atoms of each of them do you have, and when we look at that, we look at a molecule. So I'm going to deviate a little bit from talking about chemical formulas and just really talk about a molecule right now. Because one of the things that you need to make sure that you understand is the difference between a molecule and a compound. They can be the same, but they're also different. Okay? The definition of a molecule is two or more atoms bonded together. And if you think of the definition of a compound, it is very similar, but there's a major difference there. Okay? So, once again, the definition of a molecule is two or more atoms bonded together. Very similar to a compound, but a little bit different. Can anybody see what the difference is? Raise your hand if you know. What is the difference between a molecule and a compound? Yes, Eric?
Molecules can be made of the same element.
Very good. Molecules can be of the same element, and what about a compound? It has to be different elements. So the definition of a compound is two or more different elements bonded together. A molecule is two or more atoms bonded together. So examples of molecules would be O2, H2O, H2, C6H12O6. All those are two or more atoms stuck together. Now, which of those would be considered compounds, Jose? And what? Why would those be considered compounds? Very good, because they have two more than two elements. All right, so you need to make sure that you understand the difference between a molecule and a compound. Now, listen to this saying. Okay? All compounds are molecules, but not all molecules are compounds. So all compounds are molecules, but not all molecules are compounds. Okay? Say again? Very good. Okay? A square. Yeah, we know what he meant.
Like the inverse.
Okay, let me say a different one. A Tootsie Roll is candy, but not all candy is Tootsie Rolls. Okay. Tootsie Rolls are candy. Yes? Not all candy are Tootsie Rolls.
Oh, okay.
Got it?
Got it.
Okay, same thing with molecules. Okay? All compounds are molecules, but not all molecules are compounds, right? So make sure that you understand that, because when I ask you questions, you're going to have to be very careful in looking at how many molecules are there compared to how many compounds. Okay? Not all. Okay, so all compounds are molecules, but not all molecules are compounds.
Wait, all compounds.
Or molecules, but not all molecules are compounds. Okay? So make sure that you understand that are compounds. Not all molecules are compounds.
All molecules.
Okay, I have a question. All compounds are molecules, but oh.
Good for you, Ann. Dude, let me just put it all there. So all compounds are molecules, but not all molecules are compounds.
Let's go to sequence, but all and
There, I like his. Got it?
Yeah.
No problem. Alright, so, getting back to the chemical formulas, and the reason I had to say that is because when we look at chemical formulas, I will be asking things such as how many molecules are there, how many compounds are there, you need to know the difference. Okay? But going back to chemical formulas, bless you, and all these are chemical formulas, even if this is a chemical formula, it's a chemical formula for oxygen. This is a chemical formula, it's a chemical for hydrogen gas. Alright? So, bless you. All of them have different parts. So we're going to look at this chemical formula. 2H2O. That is a chemical formula for 2 molecules of water. Okay? Chemical formulas have several parts to them. The big number in front of the molecule is considered a coefficient. The chemical formula also has the symbols for the elements that are within that compound. And then sometimes, not always, do you have things that are little numbers behind letters which are considered subscripts. So in a chemical formula you can have coefficients, you can have subscripts, and you will have element symbols. So element symbols are always there. But you could have coefficients and you could have subscripts. And those two represent 2 different things. Coefficients represent the number of molecules of that chemical. So the coefficient gives you the number of molecules. So how many of them are there? The subscripts tell you how many atoms of the element that is right in front of it, or the previous element, are found in that compound. Now, subscripts are bonded to or chemically attached to the other elements or to the other atoms. Coefficients are not. So let me explain that by showing you some labels. H2O, it's 2 hydrogens and 1 oxygen bonded together. So here are my labels. Which ones are representing which color is representing my hydrogen? The dark blue, because I have 2 of them, right? And light blue is oxygen, correct? So this would be a molecule of H2O. Now, 2H2O is 2 water molecules, but the water molecules are not bonded together. So this would be 2H2O. Okay? H2O is this. 2 hydrogens, 1 oxygen bonded together. Okay? But 2H2O, that 2 is telling me that I have 2 molecules. So I have 2 of these. But these 2 are not attached. They're 2 water molecules. If they were attached, it would not be water anymore. Because it's something different. Okay? So 2H2O just means 2 molecules of this. Everybody see what the difference is? Okay? So that little 2, the subscripts, are things that are bonded. They're attached. The big 2O are things that are not attached. So if you have a little subscript, a little number, that is talking about atoms that are attached together. Okay? The big numbers are talking about things that are not attached. Those are just molecules. Okay? So, when we look at 2H2O, what basically we're looking at is we're looking at an H2O plus another H2O. So if we're trying to figure out how many atoms there are in 2H2O, we would look at these two separately. So looking at H, how many are there? 2 here, right? And 1 O? And then over here, how many H's? And 1 O? 1. Okay? So basically, what I'm seeing here is that I have 2 hydrogens, 1 oxygen, 2 hydrogens, 1 oxygen. If I wanted to know the total in this 2H2O, I just add those numbers, right? So I would end up with 4 hydrogens and 2 oxygens. But guess what? We're lazy. And we don't want to write this out, especially if we end up having something like 5H2O. Well, I don't want to write H2O 5 different times. Okay? So I'm going to show you a shortcut way of calculating how many atoms. So we're going to do 2 of them. So these are examples. 2H2O and 2MgOH2. So you want to write those down. And I'm going to show you how we're going to calculate these. So those are my examples. I'm just using a different page because I can't fit it into the page that I have. Okay. Instead of rewriting those 2 different times, we're going to do it easy. That 2 goes with H2O, right? So H2O is together, right? According to my Legos, were they not all stuck together? All right. So anytime you see a coefficient, I want you to put the molecule inside parentheses. So that's going to be your first step whenever you're doing this. You see the coefficient, and you're going to put the entire molecule inside parentheses. And now I want you to think about math. What do you do when you have a number outside of a parentheses and do it to the inside? You multiply, right? Yeah, distribute. You distribute to everything inside?
Yep.
So you're going to distribute this 2 to the H and to the O, correct? So, for H, 2 times, how many H's? 2 equals 4. Okay? Now for the O, 2 times, oh wait a minute, I have a number. Why 1?
One element.
It's like your X.
Okay? It's like an X. So if you remember in math, if you have an X, you don't have a 1X, right? If there's no number, it's an implied 1, correct? Same thing here. So 2 times 1 is? Didn't we already work that out the long way over here? Yeah. So, isn't this shorter? Yes. Alright, so now, let's do this one. So what did I tell you to do first? Put some parentheses. In this case, there's some already there, so you might want to use brackets. Same thing. So you're going to put brackets around your entire molecule. Right? Now, think of order of operations. You have brackets and you have parentheses. Which one do you do first? Parentheses.
Parentheses.
Okay? You always do the inside first, correct? Okay. So, in here, I have this number outside of these parentheses. Now, usually in math, the number's in the front. In science, sometimes you're going to have it in the back. This, too, you're going to do the same thing. You're going to distribute into those. Okay? So, I haven't done anything with these yet. If I distribute, now how many oxygens do I have? 2 times 1 is 2. And then how many hydrogens will I have? 2. Now I have a big number on the outside, so I distribute in. So by magnesium, I have 2 times how many? 1, which gives me 2. For many? Which gives me? And for hydrogen, I have 2 times how many? Which gives me? Much easier to do it this way than actually rewrite them over and over and over again, especially if I give you a number like 5. You don't want to run them 5 times, you can just multiply times 5, right? So, any questions on how we do this? Nope. Alright, so we are going to do an activity to practice this. So, I need a couple of you to pass out to everyone. Each person gets one.